In this tutorial, we are going to be adding a user-defined variable to the Sioux City Mall in our Antonio's Emporium project. The key to meter tuning is determining which variables are most important in predicting utility performance. We tune our meters for weather because some meters are associated with AC or heating equipment. Some meters may be dependent on other variables besides weather. Because metrics can perform a multivariate regression, you can select up to 5 variables to tune a single meter: heating degree days, cooling degree days, and up to 3 variables of your own. We have predicted that energy usage in the Sioux City Mall is dependent on the number of customers in the mall. Let's add a variable for the number of customers in the Sioux City Mall and tune our water meter to see if there is a relationship between the number of customers and water usage. Variables are added to area items in a project. To enter a new variable into our project, first right-click on the Sioux City Mall area and select New Variable. Under the Variable Information tab, we need to enter the name, abbreviation, description, units, and date which the readings began for the variable. Under Name, enter Number of Customers. Under Abbreviation, enter number C. Under Description, enter Customers in Sioux City Mall. Under Units, enter Customers. And under the date, let's enter January 1st, 1997. This is the date of the first day of the first read. Now let's go to the Variable History tab to enter our variable data. Data will be entered monthly starting February 5th, 1997. The number of customers for this month was 262,132. Press Enter. A window pops up asking us if we would like to add a new row. Select Yes. The date for our second row of data is 3/10/1997, and the number of customers is 386,070. Now I'm going to hand enter the rest of the variable data we have for the mall. We have now finished entering our variable data. It should also be noted that variable data can also be imported into our project as a TS1 file. Now let's tune our water meter to see if metrics comes up with a relationship between usage and the number of customers in the mall. Let's select the Sioux City Mall water item from the tree structure, and let's select the Tuning tab. We have already entered the tuning period for our meter, so we are ready to tune. Before we tune, let's switch the x-axis of our graph to outdoor temperature. Looking at the usage versus temperature graph, though there appears only to be a weak relationship, we can see that consumption increases as temperature decreases. So we would expect metrics to at least tune with heating degree days. To tune our meter, let's click on the Auto Tune button. A window pops up asking us if we would like to override the user's bill selection/deselection. Click Yes. We can see that metrics has tuned our meter with heating degree days, cooling degree days, and our number of customers variable. All of the statistical indicators have green check marks next to them, and our R-squared value is very close to 1. It should also be noted that for good tuning, T-stats must be greater than 2 for heating degree days and cooling degree days, and either greater than 2 or less than 2 for our own variables. Let's change the x-axis of our graph to show number of customers. We can see from the fit line that as number of customers increases, water consumption increases. Now let's change the x-axis of our graph to show time to see how well our regression equation matches our bill data. And we can see that our fit line matches our bill data very closely. Additional variables besides weather are used in tuning to create a baseline which most accurately reflects usage. In this tutorial, we added a user-defined variable to the Sioux City Mall area. We then auto-tuned our water meter. This meter was tuned with heating degree days, cooling degree days, and our number of customers variable.